All right.
Probably got people on the gospel choir should get 2 points bonus just for doing good last night.
Doing well last night?
Yeah.
You guys did do well, that's for sure.
Fantastic.
Okay. And I'm kind of surprised at how many, there's quite a few kids in gospel choir.
Yeah, it started out, it was only like 8 first semester.
I know.
You guys saved the show.
Did you
Oh,
do it,
no,
Robert?
the show
There
was wonderful.
No, like
We
it was
were-
good, but then they made it like amazing. You know?
Well, all that at the end, when no one would stop singing. I don't know what that was all about.
It was because like we had so many more songs that we like wanted to do, but he was like, "No, I gotta go home. I'm tired," and we were like, "No, it's our last concert." So that's what
Have you been
happened.
in it all 4 years?
No, just this year.
Oh. Okay, we need
popular.
to look at a couple of things to make sure everybody's up to speed. So I'm gonna put a scenario up here on the board. Let's say there are 25 students. All right, in the room. So here are the questions. How many ways can I arrange in a row? Excuse my incomplete sentences. I am just giving you the essence rather than taking the time to write everything out. How many teams of 5 can I pick? How many ways can I award pencil, marker, calculator? How many ways can I award 5?
Bro.
Okay, so here we go. These are questions that we should all be comfortable and familiar with. So I am missing the Shawnee. And no, this isn't a quiz. We're just getting everybody up to speed. Several people were absent yesterday. So, see what you think. All right. So I am missing Jake.
Yeah, he'll slide into it.
Shawnee.
Yeah. She showed me some of hers. Oh, wait. She showed me what? She showed me what you said earlier. What you just told me that message about how like she basically played herself. Yeah. I said, "Oh dang, that's crazy."
Oh, that's
And I walked away.
where all those people are. Oh, well. Okay, so have you got number 1 figured out yet?
Oh yeah.
The whole situation is petty.
It's going to be a huge number.
Yeah.
What did you say it was?
I didn't even write it down.
For the answer, could we put 25 in the explanation?
1.55 each.
Okay, so
Pause.
25 factorial is the setup.
Yeah.
Because if you are arranging 25 things in a row, it's 25 factorial. Now, you do need a number for that. And the calculator, when you type that in, pulls up with this. Now, on the calculator, it doesn't say times 10 to the 25th. What does it say? E. You got to remember that the E means times 10. That's your scientific notation.
So on a test, if I just put 25 factorial and I didn't like put the number, is that just like half off? Or?
Minus an eighth.
Okay.
Just an eighth. Not a huge deal, because the setup is the most important part. But you are supposed to have a calculator and you are supposed to know how to use it. So
Okay.
I'm going to take off a little bit if you don't. All right, are we good on number 1?
Yeah.
All right, number 2. Say 25 students. I'm gonna I need to pick a team of 5. How many different teams of 5 could I pick, Jonathan?
Would be 25 to the 5th.
No, that's a good guess though.
24, 25.
Now, okay, here's what I want you to think about. First of all, I understand Jonathan, 25 to the 5th. He's saying you have 5 spots on your team to pick, right? So he said 25, 25, 25, 25, 25. Well, no, because you have 25 choices here, but here you would only have
24.
24. But that's still wrong. That's still wrong. Because if you are picking a team of 5, the order that you pick them, 1st, 2nd, 3rd, 4th, 5th, doesn't matter. If you're picking a team of 5. The minute you put blanks up here to fill in, and that's okay, it's fine to do that, but that means you're doing it in order, and there's no order in this problem. This is, what did we say yesterday? We had 2 ways of picking 5. Raven? Raven? You do. This is 25 C5. Now, the 25 is because there's 25 kids to choose from. The 5 is because you're picking 5. And the C is because the order that you pick them doesn't matter. Okay? Kids, if this were a P problem, the blanks would be okay. I understand that because I'm old and I'm the teacher. Let me just suggest that anytime you are picking from a group, you do either P or C. P if order matters, C if it doesn't. Don't try to draw a picture of it. If it's a P problem, that'll be fine. If it's a C problem, you're going to miss it every time.
How do you get C?
Those are your combinations. Did you watch the video from yesterday? Okay, you need to do that. Okay, because we went through all that yesterday. So you need to watch that so you have that foundation. I can't reteach it because it took me a whole period yesterday. Now, if I had to pick these people in order for some reason, whatever it was, I was picking them in order, like president, vice president, then I could do the blanks if I wanted to, or I would do 25 P5. Okay? Now, anybody got this typed in on your calculator? 25 C5 is
53,130.
You guys
Okay,
are
mathematicians.
It's 25.
You right. Never said I was right.
Then go all the way to
What?
So did you say 53,130? So there are that many different teams of 5
We're no longer
that I
friends.
could
We're no
choose.
longer friends.
All right, let's look at number 3. Now, forget the specifics of the problem. What's really going on here? There's 25 people, right? And what am I going to do? I'm going to pick, no, I'm on question 3 now. I am going to pick 3 of them to get a specific prize, right? I'm giving away 3 different prizes. So I'm going to pick 3 of you. Does it matter if I pick Joseph first or second? Is that going to change for him? Oh, yes, it is. Because if I pick Joseph first, he's getting a pencil.
So they were getting all free.
No, one per
I'm picking 3
winner.
people, and you get 3 gifts. Each of you gets a gift.
Every person got all free gifts.
No.
It's okay, son.
I'm picking 3 people to get prizes. And whoever I pick first is going to get the pencil. Whoever I pick second is going to get the marker. And whoever I pick third is going to get the calculator. Does it matter to you what order you get picked in? It totally does. So this would be 25 P3. I have 25 kids and I'm going to choose 3 of you, and the order I choose you matters. So 25 P3. $13,800. So there are 13,800 different ways I can give away my prizes.
Wow.
Now, we've done an example of choosing people and the order didn't matter. Now we've done an example of the order does matter. I want you to read this last question and tell me what your setup is going to be. Austin?
25
It is, Austin. And what is your logic? You are right on. What is your logic?
Because it doesn't matter because everybody gets the same thing.
Exactly. Now, it doesn't matter if I pick Joseph first or not, because if he gets picked, he's getting a pencil. If I pick you next, you get a pencil. It doesn't matter. Everybody's getting the same prize. This is like a committee. This is like president, vice president, treasurer. Do you see that? If you are picking for a specific job, a specific present, whatever, that's order. Order matters. But if you don't care, if it's all the same, if you're just on the team or getting a pencil, then order doesn't matter. Okay? All right, let me put another one up here. A couple more, real quick.
So in what cases would we go 25, 24, 23?
You can do that at any P time, any P problem, you can do
Oh,
that.
okay. So basically everything would like the.
If order matters, you can do that.
Okay. So for every problem, we either do factorial, C, or B.
No, because we have a problem like this. Suppose you're going to make a sandwich in the cafeteria, and you got to have bread. You got to choose bread. You got to choose meat. You got to choose cheese. And there are 4 different kinds of bread, 5 different kinds of meat, and 3 different kinds of cheeses. So the question is, how many different sandwiches would be possible? So everybody has to have bread, meat, and cheese on your sandwich. Everybody's got to have that. But we got all these things to choose from. So how many sandwiches would be possible?
Well,
60.
no, wait,
60. 60. 60.
Yeah.
Because you have 4 choices of bread. You go down there and you pick a bread. You got 4 choices. Then you have 5 choices of meat. Then you have 3 choices of cheese. Remember the license plate problem we did yesterday?
Yeah.
This is like the license plate problem. Only instead of picking letters and numbers like we did for the license plate, we're picking bread and meat and cheese. So you have that kind of problem too. All right, let me try another one. Let's suppose that there are 10 teachers, and I need to pick 4 for an academic council. I need to pick 3 to give cookies, brownies for candy kisses. I need to arrange them in a row. And I need to pick 2 to go on a trip. Alright, so here we go. What's your thought on problem number 1? Remember that there's only 10. We're starting with 10 teachers. I need to pick 4 for an academic council. 10C4. If I'm picking them for a council, that's like a committee, right? I have to pick 3 one of them's gonna get cookies, one of them gonna get brownies, one of them's gonna get candy kisses. What's that?
10P3.
10P3. What if I gave everybody cookies? 10C3?
Yeah.
10C3? If I gave everybody the same thing? How many ways can I arrange them in a row? 10 factorial. How many ways can I pick 2 to go on a trip? What? 10 P or C? C. Why is it C? Because if they're both going on the trip, order doesn't matter. Now, if I were going to pick one to go to Venezuela and one to go to England, then it would matter which order I pick them in, right? But if I am just picking 2 of them to go with me on a trip, then there we go. Okay? All right. I think I'm going to hold off for a quiz till tomorrow and practice a couple more things right now. So here's what I want to do. I want to give you no, we're not going outside. And we're not playing football.
You know we don't have this class tomorrow. It's cool.
Well, I guess it's the next day. Alright, yeah, I just feel like we need to practice a little bit more.
Go back, Chris.
We're not even friends. We're not even friends.
I guess I could give you a little quiz.
No. Alright.
Hey, man. Stop, man. That's not
Practice.
Are you cool?
I brought it. Normally it's in the closet.
Thanks, man.
Okay. All right, so we're going to look at the front page of the practice test here. Don't look at this. We're not ready to do all of these yet, but we're ready to do some of them. So let's see how many of these we can get done. And today we're going to talk about some of the probability stuff at the bottom. But let's see how many of the first ones we can do. How many ways can 7 books be arranged on a shelf? 7 factorial. Ow. Does that make sense to everybody?
Mm-hmm.
How many outfits are possible if you have 4 pairs of pants and 6 shirts? 24. 4 times 6. That's it. You go to your closet and you pick a pair of pants. If you want a picture of that, here are your pants choices. Let's say they're blue, green, red, and black, orange. Okay? There they are. Now, if you pick your blue pants, then you have 6 shirts that would go with it, right? And if you pick these, you have 6 shirts that could go with it. You're going to end up with 24 altogether, because each of these branches is going to have 6. So you're going to have 24. 4 times 6. How many ways can you answer 8 true false questions? We did this one yesterday.
16? No.
8 true false questions.
16.
I thought it was 16.
Yeah, I did too.
Nice. What is it?
18. That's
I
interesting.
didn't say 18.
Oh, what'd you say? Oh, you said 18. Here are your 8 questions. And before you say anything, when you get the test, there's question number 1, right? There it is. How many choices do you have for question number 1?
2.
2. How many choices do you have for question
2.
number 2? 2. So what is it? 2 to the 8. That's exactly right. 2 to the 8. Why 2 to the 8? Because every question has 2 choices. What? 256 maybe?
Yeah.
How many ways can I give a pencil, a marker, and an eraser to 3 students in a class of 12? 12P3. Uh-oh. How many 8-letter words can be formed from the letters of prettier? Alright, here we go. How many letters are there? 8. So we start with 8 factorial, right? Now, why am I putting that line there? Because some of them repeat. There's 2 T's. So I'm going to divide by 2 factorial. There's 2 R's. So I'm going to divide by 2 factorial. And there's 2 E's. So I'm going to divide by 2 factorial. Right? And when I type that in, because it has more than one thing in the bottom, I am careful to put that in parentheses. So as a double check for those of you that want to make sure you're typing this in correctly, you should get 5040. 5040 should be the correct answer. Make sure you're putting the whole thing in one big set of parentheses.
Trey. Watch out.
Now, I can't remember, did we talk about number 6? I didn't put any examples up here today. How many ways can 10 people be seated around a campfire? Actually, it's not 10 factorial. The difference here is if I said, how many ways can I seat 10 people on a log? That would be 10 factorial. When I put them in a circle, it's actually 9 factorial. And the reason is, I don't want to, 10 people is too many. Let me just do 4 people, or let me do 3 people. If I have 3 people in a row, here they are, A, B, C. They could be ACB, they could be BCA, BAC, CAB, and CBA. If I had 3 people, and I'm seating them in a row, that's 3 factorial, right? Which is 6. There are the 6 ways. Does that make sense to you? Now, let me put those same 3 people in a circle. So let me just take these arrangements, each of these arrangements, and make a circle out of them. So like here's ABC, there it is, ABC. And here's ACB, BCA, BAC. Now remember, these are circles now. I'm arranging these in circles. These people are seated around the circle. CAD and CBA. Now I want you to look at those circles. Think about these people are seated in circles. Look at that for a minute and tell me what you notice. Take a look at this one here, and this one here. Take a look at those 3. And think about if you were seated at that table with those people, what do you notice about this arrangement, and this arrangement, and this arrangement?
It's a new letter up top.
They're all the same. They're all the same. What did we do? We just took our table and rotated it. When you put things in a circle, you have to remember circles rotate. They're not broken. Lines have a beginning and an end. These have a beginning, a first guy, and a last guy. Circles don't have that. So instead of there being 6 ways, there's really just 2. There's the 3 I have checked, and then the other 3 are all the same also. Here's the general rule of thumb. When you arrange things in a circle, it's 1 less, factorial. So 10 people in a row is 10 factorial. 10 people in a circle is 9 factorial because of the rotational effect. How do I know this isn't a circle? It says around a campfire. Okay? So go back to my examples earlier. Remember when I had 10 teachers and I said how many ways can I arrange them in a row? You said 10 factorial. What if I said how many ways can I arrange them around the table in the faculty lounge. 9 factorial. Okay? Circles, 1 less factorial. We're going to do one more, then we're going to talk about probability. Number 7. How many committees consisting of 3 boys and 5 girls can be formed from a class of 10 boys and 8 girls? So I have 10 boys and 8 girls, and I'm going to choose 3 boys and 5 girls. Any ideas about that? Eric? Oh my gosh, you are so close. First of all, let's start with this part right here. This is it. This is the beginning. He said, okay, I need to pick 3 out of the boys. 10C3. Why did he pick 3? Or C, I mean, why did he use C? Order doesn't matter. It's committee. Order doesn't matter. Then he did the same thing with the girls. Now, for this committee, I have to pick boys and girls. And what did I tell you yesterday about the word and? When you're doing this and this, what do we have to do? Multiply. So Eric, you had it right on, except it's a multiply. Because I am picking boys and girls. Okay? Now we're kind of going to do the same thing here, so we're going to get out our note sheets. But I want to do one more example of this that's going to pertain to probability. Suppose you have a standard deck of cards, and you want to know how many hands contain exactly 3 clubs. So how many? This is exactly the same problem as Eric just did. Instead of having boys and girls, what does he have? He has clubs and other cards. How many clubs are in the deck altogether? Altogether, how many clubs are in the deck?
6.
Oh, you guys play cards? No one plays cards? 4 clubs? 13. Very good. 13. There's 4 suits, guys. How many cards are in the standard deck? 52. There's 4 suits. Hearts, right? Clubs, spades, diamonds. So 52 divided by 4, 13. How many other cards are there then that aren't clubs? How, 39? Yep, 39. How many of these do we want? 3. So we'll do exactly what Eric did. We'll say 13C3. Oh, I didn't tell you this was a regular 5-card hand. How many 5-card hands? So here's my 3 clubs. How many other cards do I still need? If I gotta have 5, I need to pick 2 more. And they're coming from the other cards. So 39C2. You guys are usually the group I can count on. You're all like zoned out. What's going on? Tired?
Yeah.
Okay, well, all right. Let's get our note sheets out, pick up where we left off. Actually, we're not going to pick up where we left off. We're going to skip ahead. I got to find them. I just had them. I need you to skip to page 59. We're going to do a little skipping around here. I need you to skip to page 59. And we're going to spend some time with some probability problems, all right? Here we go. Page 59, number 9.3, number 1. Maggie and Elizabeth have a bag of M&Ms. They each have their own bag. Each girl has counted the M&Ms and has discovered the following proportions. Okay, so what it means in Maggie's bag is 30% of the M&Ms in Maggie's bag are green. That's what 0.3 means, 30%. 20% are yellow, and so on. For Elizabeth, the numbers are different. 20% of hers are green, and so on and so on. So do you understand the scenario?
Yeah.
All right. So question number 1 is this. I'm going to pick a candy from Elizabeth's bag. Just Elizabeth. What is the probability it will be green?
30%.
Elizabeth.
Oh, that's
I mean 20.
20%. So A is simply 20% or 0.2. You can answer as 0.2, you can answer as 20%. It doesn't matter. Now we're going to pick one from Maggie's bag. What is the probability that it will not be yellow? So be careful. We're picking one from Maggie's bag. The probability it won't be yellow is 80%. Does everybody get that? Joseph. If a candy is chosen from each bag, what's the probability it will be red?
25.
So we're getting, now wait, we want to get red and red.
50.
So what's the probability it'll be red out of the first bag?
Oh,
0.2. What's the probability it'll be red out of the second bag? 0.3. Now, and. What operation do I do when it's an and? Multiply. So the answer is 0.06. Probability being red out of the first bag and red out of the second bag is 0.06. See how that works? All right, D. What is the probability that neither will be brown? So in other words, for D, I want not brown and not brown. All right, so what's the probability it won't be brown out of bag 1? 0.8. And not brown out of bag 2? 0.9. So if I want this and this, I'm going to multiply those, and that's 0.72. So there's a 72% chance that you won't get any brown ones. Okay, a candy is chosen from each bag. What is the probability that the first one will be green and the second one will be blue? Here we go. First one green.
30%.
0.3. Next one blue.
2.2.
0.2. And multiply. Answer is 0.06. If a candy is chosen from each bag, I'm now on F. So if a candy is chosen from each bag, what is the probability that one will be blue and one will be green?
0.6.
Didn't I just do that?
0.06%.
I'm hearing something. What am I hearing back there?
0.06%.
So it says I need one green
2%.
and one blue, right?
yeah.
Now, let's think about this for a second. This one was green, then blue. And that answer was 0.06. Does it have to be green then blue? Could it be blue then green? And what would that be? blue out of the first bag. What was it? Am I using the right letters? Yeah. So blue out of the first bag is 0.1, and green out of the second one is 0.2. Oh wait, yeah, blue out of the first one's 0.1, green out of the second one's 0.2. So what's that? 0.02. So what is the answer to the question? What does the OR tell me to do with these two numbers? OR, add. OR means add, total them up. So you have 0.08. Your answer is 0.08. This is going to be one of the trickiest parts of the test. There are quiz, whatever we end up taking. There are some tricky parts to this. One is the whole PC thing. I think we've got that figured out. P if order matters, C if it doesn't. The other is keeping track of the differences between questions E and F. E says, what is the probability the first one's green and the second one's blue? That's it. Green, then blue. Problem F says, what's the probability that one of them is going to be blue and one of them is going to be green? Do you see the difference between those questions? If I need one to be blue and one to be green, then I can do it in either order. I can get green, blue, or blue, green, right?
Order matters in the
Order, so I got to consider that. And then I'm going to add those two together, those two possibilities. Green, blue, blue, green, add them together. Because it could be that or that.
So when you took green then blue, you got 6%, right?
Green then blue was 0.3 times 0.2, yes.
And then blue then green, is that from the second bag or from the same bag?
No, you're taking them out of, you're saying Maggie's bag 1, Elizabeth's bag 2. I'm choosing out of bag 1 and then out of bag 2.
Oh, okay. Got
Okay.
it. So, because I was about to say, if you're taking it out of Maggie's bag both times.
No.
Okay.
Yeah.
Gotcha.
Alright, and G, if a candy's chosen from each bag, what's the probability you'll get no reds? Neither will be red. Not red and not red. So what would that be? Not red and not red.
It'd be 0.8.
0.8 times 0.7. So 0.56 is your answer. Not red, not red.
You want to answer percent?
You can answer decimally or percent, whatever you're comfortable with. Some people like to answer in percents, and I'm fine with that. The decimal is what your calculator's going to say, so if you just want to write that down, that's fine too. All right, now we're going back to a 5-card hand from a standard deck. All right, so we're going to get part of this done today. We have to. So hang with me. How many 5-card hands are possible? Robbie, this is cards. This is like fun. This is like games.
I don't play cards. Play Uno.
Okay, well there's cards in Uno. They're different than these cards, but there's cards in Uno.
Go fish.
Go fish. You can use this deck for go fish. All right, how many 5-card hands are possible?
How many cards are in the deck?
52.
13.
And how many am I picking? 5. Does the order matter? No. So the answer to the first one is 52C5. That's the answer to A. Why 52? Because there's 52 cards in the deck. Why 5? Because I'm picking 5. Why C? Because order doesn't matter. What is the probability of being dealt a hand with all diamonds? Well, how many hands would have all diamonds? So let's start there. This is the total. This is every hand possible. How many have just diamonds?
52. 4.
What?
Never mind.
How many diamonds are in the deck?
4.
4. 4. 8. Guys.
13.
Yes. There's 13 diamonds in the deck, and you're going to pick 5 of them. Do me a favor, and sometime between now and our next class, look at a deck of cards.
1,287.
Okay, now wait. That's how many hands there are. The question is, what's the probability of getting a hand like that? So what would I do? What'd you say? I'm going to divide it, not by 52, but by 52C5. Because these are the number of hands that have all diamonds. And what are these? The total number of hands. So these are all diamonds. These are the all diamond hands, and these are the total hands. And when I do probability, don't I divide by the total? Isn't that how probability works?
We got some
What did you get?
like 4.9519 to the negative fourth.
So in other words, 0.000495.
Percent. Oh, that's the
No,
probability.
actually, that would be the decimal. It would be
Yeah.
0.0495%. Now, that's a very small percentage, but I want you to stop and think about it for a minute. Do you get all diamonds very often? No. The probability is very small that you're going to get all diamonds. Does it happen? Sure, but not very often. What is the probability of being dealt a hand with all face cards? We're going to do a couple more, so hang on. This might be the last one, actually. Last one. We'll finish with this one. What's the probability of being dealt a hand with all face cards?
How many face cards are there?
I don't know. Let's figure it out. What are the face cards?
Ask Sherry.
Jack, Queen, King, diamonds, and spades and hearts and clubs. 12. There's 12 face cards. So your numerator would be 12C5. Because there's 12 face cards and you're picking 5. Divided by 52C5. Jonathan, that's even a smaller number. Because since there's fewer face cards, that your chances of getting 5 of them is smaller than your chances of getting all diamonds. Very small numbers,
Yeah.
right?
Yeah.
All right, next time we're going to have a quiz. So if you have not yet watched the videos, all of you that were absent yesterday, you need to do that. Get yourselves caught up.
This has been brought to you by Mrs. Ford C. Period class.
You are
Peace.